So in this video, we're going to talk about how we can utilize a graphing calculator and its linear regression function and utilize our knowledge of finite differences to create an equation for a polynomial function. So if you have a graphing calculator, you'll be able to do this, pause the video, go along with me as you actually do this on your calculator. If you do not have a graphing calculator at home but utilize ones in the classroom, what I suggest you do is take detailed notes about what buttons we're pushing, so that you can do this on your own when we get into the classroom. So we're going to start with the example that we left off with in slide 3 of our previous video. So here you can see that we used finite differences, and in doing so, okay, this was our first difference, our second difference, and our third difference is where we had a non-zero constant result. So we know that this is a third degree function. And we know that a third degree function is called a cubic. Now, we need to use finite differences to find that because we have to know what type of function we're writing an equation for if we're going to actually write an equation for it. So to start off here and use linear regression on our calculator, first we need to turn it on. So you can see that my calculator is on. And what we're going to do is we're going to access where the lists are and where the statistical functions are on our calculator. So if you press this stat button, it's going to pop up with a couple of different things, and it says edit, calculate, and test. What we're going to start off doing is we're going to edit our various lists. So I want you to click enter once you see that it's on the edit. So remember, we clicked on the stat button, and now we're going to edit our lists. Now, we can enter in many lists, and what we're going to do here is in list 1, we're going to enter in all of our x values here. So we're going to enter in 1, and 2, 3, 4, 5, 6, and 7. So we can see that is in our list. We entered in all of our x values. Now on list 2, if I pop over, I'm going to enter in my y values that correspond with it. So list 1, I'm entering in all of my x coordinates. And in list 2, I'm entering in all of my y coordinates. So 1, 4, 10, 20, 35, 56, 84. So what you can see here is you can see that between my two lists, I have all of my x coordinates over here in list 1 and my y coordinates over here in list 2. So that's the first piece. You actually have to enter in the data that you have. So remember, we clicked on the stat button, we pressed enter to edit them, and now we're editing our two lists. So that's the first step there, is entering in your data. Now the second step is we're going to go back to the stat function, and we're going to go to calculate. Now you'll notice here that there's a couple of different ones. We can do one variable statistics, two variable statistics, then there's a linear regression one, and here we have quadratic regression, cubic regression, quartic regression, and that's kind of where it stops. But what we can do is we can use, if we know that this is a cubic function, we can actually utilize data in a list in order to calculate an equation for that situation. So what I'd like you to do, and remember to get here, we pressed stat, and then we went over 1 to calculate. So press stat, go over 1 to calculate, and I want you to go down to the cubic function. And then we're going to press enter. Now, what this is asking you for is it's saying, where did you store your data? Because in order for your calculator to actually create a cubic function to represent this data, it needs to know where your data is stored so it can look at the data. So here we have our x values, our list 1. Now, if this wasn't in here, say these were blank and you needed to add them in, what you can do to access your lists is, if you notice here, there's a little blue word here that says list on my calculator. To access that, I click second, and then I click on stat again, but I'm really going to access list. And here I can access my many lists. And if I want list 1 in that spot, I just press enter. So I'll repeat that one more time here for y. Again, say this was blank. I'm going to press second, list. Remember, the list is the blue. And I'm going to scroll down 1 to get list 2. So you do have to remember where your data is stored. I put my X list in list 1 and my Y list in list 2. So then from here, I'm going to go down to the word calculate and I'm going to press calculate. And what this actually does is it goes through, and this is a cubic function written in standard form. It's saying ax cubed plus bx squared plus cx plus d. And what this found me is my equation. It found me the a, b, c, and d. So it found me the coefficient of x cubed, the coefficient of x squared, the coefficient of x, and my constant value for my equation. So here I can write, okay, f of x is equal to, then I have my a value of 0.16. I'm going to round to 7 there. And that's x cubed. And then I have plus, well, my b value is 0.5, so I have 0.5 times x squared plus 0.333 times x, and then my d value is 0, so I don't need to write it out. So this particular function here represents the data in this table. It is the cubic function written in standard form to represent this data. So it's pretty cool that we can actually utilize that to make a prediction about what the equation will be. Now we're going to do one more example together here. This one is a real world problem filled with data. And so if we read through, we notice it says the table shows the total US biomass energy consumptions, Y, in trillions of British thermal units is in the year T, where T equals 1 corresponds to 2001. So this table starts in 2001, goes all the way up to 2012, and shows the British thermal units in trillions of the energy consumption of the US. So you can see that it's going up over time, because this is real world data, it's not perfect. So we can use finite differences here, but it's not going to be perfect data because it's real world and real world isn't always perfect. But what they do tell us is that we know the data here is modeled by a cubic function. So what we're going to do is we're going to create an equation or a polynomial model for this data. We're going to plot this data, and we're going to have the calculator create a polynomial cubic function, and then we're going to use that function to help us estimate the energy consumption for 2013. So I'm going to clear this out, and I'm going to go through this process one more time. Because I know this is a cubic, I do not have to use finite differences. If I didn't know that this was a cubic, I would need to use finite differences because I would need to know, is this a quadratic or something with degree 2? Is this a cubic or something with degree 3? Or is this quartic, something with degree 4? So you have to think about which one you're going to use. So this one I know is a cubic. So I'm going to go back into my stat. I'm going to edit my lists. Now I know that I need my list to be cleared. So I'm going to scroll all the way up. Notice how I put my cursor on L1 here. And I'm going to clear L1 out. Now, there we go. So you might have to press enter and then go down a couple of times. Now, if I go over to list 2, again, I'm going to go up here. I'm going to press clear. Notice it's gone and scroll down. So to remind you one more time of what I did, I scrolled up, highlighted the list I wanted to delete, pressed clear, and then when I scrolled down, the entire list deleted. Now I'm going to type in my new list here. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I've entered in my list 1. Then I'm going to scroll over and enter in list 2. So we have 2,622, 2701, 2807, 30, 10, 31, 17, 32, 67, 34, 93, 38, 66, 42, 86, 44, 21, and 4316. So I have now entered in all of my values. If I kind of scroll back up, I'm just going to double check that these are correct. So 4316, 4421, 4286, Oh, it looks like I missed one in there. So good thing I double checked. So this would be 39.51, 42.86, 44.21, and 43.16. So again, I'm just going to scroll and make sure I got them all right because it's really easy to make a mistake as you enter these. 39.51, 38.66. I can see this one I typed in slightly wrong. That should be 34.93. I keep going, 32.67, 3117. That one's correct. Good. Okay. So just double checking your list is really helpful to make sure that you didn't make an error as you entered. So I've now entered in my lists. I can now go back to the statistics function here. I can go over to calculate. And then remember, I can utilize these regression functions to help me calculate a function to represent the data. Now, just to remind you, a linear regression function, if you want to make a note, this is for degree 1. So if you have something that's degree 1, you use a linear regression. Quadratic is degree 2. So make a note that if you have a quadratic, you're going to use degree 2. Cubic is degree 3. So make a note that if you use cubic, that's degree 3. And a quartic is degree 4. So make sure that depending on your data, this one is a cubic, but for some it may be fourth difference where you find that it's a constant, so you use a quartic, or maybe you find it at 2, so it's a degree 2 function. Make sure you use the correct regression so that you don't get confused about the pattern that you have. So here we have cubic regression that we're going to be using because they told us it was cubic in the beginning. Now, my lists have already defaulted in here, but again, if you forgot how to get your list in here, you click second, then you click the stat button to access the list, and then you can access your list name. And make sure you have list 1 in for your X to match where you put your X values, and list 2 in where you put your Y values. So then we go down here, and we pressed calculate, and there we have our equation. So from here, we can see that we have coefficients for A, B, C, and D. I'm just going to round to about 2 decimal places here. But my equation would be y equals negative 2.55 x cubed. And then I have plus 51.95 x squared minus 118.11 times x, and then plus 2732.14 for my constant. So I have this function, which is great. My last step here is I'm going to estimate the energy consumption for 2013, which means I'm going to take 13 because that number represents 2013, so 13 would be the next year here. And I'm going to substitute this in for every x value. So if I take 13 and I substitute it in there, so I have negative 2.55 times 13 to the third plus 51.95 times 13 squared minus 118.11 times 13 plus 2732.14. What I end up with is an approximation using my equation of 43,700 or 4,373, read that wrong, 0.91. And then that would be in British trillions of British thermal units. But that's my approximation. And if I look, that appears to follow the pattern that I was seeing here. So regression is really helpful when we need to actually find an equation to model the function that we are working with. So hopefully you can utilize your calculator now in order to do that.